if you don't mind, I just would like to know where you're coming from. So maybe if we take a couple minutes and everybody will say who they are and where they're coming from. I know where you're coming from.
Well, I'm a language teacher. Hi, my name is Sylvie. I'm at the Traditional Languages Institute, and my area is language policy and planning.
Great, thank you.
My name is Natasha Artemeva. I'm also my area is second language acquisition.
Thank you. Oh. Thank you.
I'm Monica Nevins. I'm the chair of the Department of Mathematics.
Thank you. Thank you. Well, great to meet all of you. Today, I would like to. I have a 50-minute.
Yes, you have 50 minutes, and then we'll have 20 minutes.
Okay, excellent. So I have 50 minutes. That's amazing. I'm going to talk about the study that my colleague Jenna Fox and I have been involved in since 2007. It's a study in which we explore pedagogical practices of university mathematics professors and instructors, and also PhD students and postdocs. So we decided to call them university mathematics teachers, just for convenience, not to be confused with school teachers. So the title of my presentation today is Beyond the Word, Pedagogical Practices in the Undergraduate Mathematics Classroom. It's a SSHRC-funded study. Okay. So the outline for today's presentation is in front of you on the screen. I will start with explaining why we decided to run this study and what made us interested in this particular area of studies. And I'm going to talk first of all why we decided to study university mathematics, because my colleague Gianna and I both work at the School of Linguistics and Language Studies at Carleton, which people often question, how can you study mathematics if you're not in the Department of Mathematics? And also why we started this huge international study. And then we'll go into the nitty-gritty of the study. We'll talk about definitions, research questions, why the title of my presentation today is Beyond the Word, and the actual study. Snippets of the study, I would like to say, because it's a large study still ongoing. So, first of all, why university mathematics? As you all know, in North America and in Europe, mathematics is very often referred to as a gatekeeper, limiting access to higher education, to jobs in engineering, science, economics, so on and so forth. And there has been evidence-supported opinion that mathematics skills of high school graduates and university students have been deteriorating. And universities have been reporting higher failure rates in entry-level university courses, which of course leads to financial burden on universities and loss of students, and also social consequences for society. There's been a lot of talk about science, technology, engineering, and mathematics education, STEM, for which mathematics is central. And STEM disciplines are considered also extremely important for the development of current economic situations in the Western world. And in the States, for example, according to a 2012 report, elementary, secondary students are falling behind, and therefore they are falling behind in their STEM courses or not even getting into STEM courses at the university level. I'm sorry, I don't know how to use this. Monica, I don't understand how to use it.
You want to exit it?
No, I just want to get where I need to get. I don't think I'm going back. I think I'm going forward all the time. I apologize for this.
Okay. Previous.
Use the keyboard. Use the keyboard, the arrows.
There's no keyboard.
Oh yeah, there is. Yeah.
Oh, thank you.
Okay.
That's excellent. Thank you so much. Okay, and as well, Canadian researchers have been reporting falling scores for school students and engineering and STEM students in universities. On the other hand, there's more and more students who are pursuing careers in these areas. And especially nowadays, with a recent report in 2012, it's an American report, among minorities and women. However, it seems that the focus is shifting from North America. And for example, 56% of the world's undergraduate engineering degrees were awarded in Asia in 2008. So all this is a cause for concern. Existing research is very limited in the area of university mathematics teaching. There's a significant number of studies that focus on teaching mathematics in elementary, secondary school. Very few focusing on teaching mathematics at university. There's a lot of criticism of how mathematics is taught at university. You might have heard criticism of what is called transmission model, when people talk about lectures, where the professor is not interacting with students, but rather transmits knowledge. And there have been calls for changing teaching practices in the university mathematics classrooms. On the other hand, there is a small but growing number of studies that challenge this view and demonstrate evidence that the way mathematics is taught at university serves as an initiation of the students into the practices central to the discipline of mathematics. And therefore, the changes to these central pedagogical practices in university mathematics without appropriate research may well prove harmful to students, as Pritchard notes. Such contrasting views suggest a critical gap in our understanding of university mathematics pedagogical practices and interactions between teaching and learning mathematics in university. Today, I'm going to focus on teaching practices. In this part of the study, we're not looking at students, or in the study that was funded by SHRC, The funding has ended last year, and now we are applying for a new grant in which we're going to look at the interaction between the pedagogical practices and the actual student learning of mathematics. But this hasn't happened yet. So my presentation is fully dedicated to how mathematics is taught and why it is taught in the way it is. So there are studies that actually look at the transition of students from school to university mathematics. And these studies also reflect the existing gap between what students learned or how students learned in secondary and high school and what they're facing at university with, once again, distressing numbers of failures. And apparently, there's no documented help that so-called remedial options offer students on campus. Another opinion by a mathematician is that many people see mathematics only as a collection of arcane rules for manipulating bizarre symbols, something far removed from speech and writing. Most elementary and high school courses are procedural courses focusing on techniques for working with numbers, symbols, and equations. In other words, focusing on symbolic manipulation. And while, of course, nobody argues that formal technique is extremely important to learning and doing mathematics, it's only as good as it gets if you understand what mathematics is about. At university, conceptual mathematics courses are focused on proof and argument, and university courses, which are more advanced, are concerned not just with manipulating symbols and solving equations, but with understanding the interrelationship among a whole host of sophisticated concepts. And clearly, there is a difficult but crucial leap that students need to make when transitioning from secondary high school to university, from rudimentary to advanced mathematical thinking, and I would say from rudimentary to advanced mathematical language. My other question that sets the premises of this study is, why was an international study necessary? When we just started our research at the pilot stage in 2007, we have observed several classes in Canada and realized that mathematics departments were extremely diverse in terms of their faculty. Professors in mathematics departments in Canada at that point came from very different countries, spoke very different first languages, taught in their second, third, fourth language in Canada. And regardless of that, we observed incredibly similar trends in how they taught mathematics. So the diversity of mathematics departments in North America definitely reflects common internalization, globalization trends, and all mathematics departments we eventually observed in our study demonstrated extraordinary cultural and linguistic diversity. If we look at the list of the Fields medalists, and Fields medal is, correct me if I'm wrong, was founded as a counterpart to Nobel Prize because there's no Nobel Prize for mathematics. So it's the highest honor that a mathematician can get. So many award recipients speak first languages other than the languages of the countries where they teach. Out of 13 award recipients in the period of 1990 to 2010, currently working in the US universities, 11 out of 13, 11 were born and educated outside the United States, with 8 of these speaking first languages other than English: Cantonese, French, Hebrew, Russian, Vietnamese. So, given our preliminary understanding of global context in which mathematicians, university mathematics teachers and mathematicians work, we definitely started thinking about conducting an international study. And given the international labor mobility that keeps increasing, including university faculty and university students, PhD students, and postdoctoral fellows, which is a staple feature of university mathematics community, we made this decision to start an international study. So with a few definitions, I'm talking about mathematics. I can't start my presentation without introducing definitions. So with a few definitions of the terms that we're going to use, I'm going to use in this presentation, we understand teaching within a discipline as a kind of rhetorical accomplishment realized in the social practices and discursive accounts of key stakeholders. By key stakeholders, we see professors, students, university administration, and society as a whole, because society benefits from students who are good at math and finds it problematic when the majority of the population is failing mathematics. Also, working with the terms such as globalization and internalization is very hard because they are defined differently in almost every single article you would read. So what we decided to use in our study is we decided to follow Knight 2004 and see internalization as emphasizing the notion of nation, and globalization is referring to worldwide in scope and substance. And you will see how this plays into our research later. Now we're going to talk about, in the context of internalization and globalization, we're going to talk about different contexts that we were studying. So global context for us is the teaching of mathematics in university classrooms around the world. We focused mostly on lectures because lectures draw the most criticism because of the perceived transmission model. However, it is important to understand that mathematics is not taught through lectures alone. There is the cycle of lectures and problem-solving sessions and tutorials and so on and so forth, which cannot be teased apart. So when people talk about teaching mathematics at the university and thinking that this is just lectures, this is not an accurate perception. Local context for us is the teaching of mathematics in a unique classroom situated within nested contexts, which include cultural, institutional, national, linguistic, social, and so on and so forth. Geographical as well. And by culture, we understand a site wherein knowledge is communicated and instantiated, negotiated and contested, reproduced and transformed. That is, we do not necessarily treat culture as national culture. Every discipline has its own culture. Every institution has its own culture for us. So our research questions in this study, two of our research questions. were what are the pedagogical practices of university mathematics teachers in the current environment of globalization and internalization of higher education? And are these practices realized differently by veteran and novice teachers in different contexts? One of my interests, my research interest that I have pursued for many years now is how novices learn how to become professionals, how to walk the walk and talk the talk. And I looked at engineering students and how they were becoming engineers. And in this study, we also focused on how novices, that is, sometimes even master's students who worked as teaching assistants, PhD students, postdocs, new professors before their first sabbatical, how they, what kind of pedagogical practices they used, and how they used these pedagogical practices as compared to veteran mathematics teachers. Now, going back to the title of my presentation, why is it beyond the word when we look at a mathematics classroom? What I mean by beyond the word is beyond the written word on the board and beyond the spoken word. So at the beginning of our study, when we observed multiple contexts in different contexts, both global and local, in different countries, in different languages, we noticed that across all observed contexts, teachers of mathematics at university were engaged in the same pedagogical practices, which may be not surprising for people who understand mathematics and who teach mathematics, and may be very surprising for people who teach social sciences and arts. And we came to call this sum of pedagogical practices that were realized through multiple resources. We came to call it the chalk talk. And you know, as chalk talk has negative connotations when people talk about classroom practices, teaching practices, in this presentation and in our work, this term doesn't have any connotations. It's a descriptive term. We use it to describe what is happening in the classroom when the professor is teaching. So chalk talk includes all these elements that are written on this slide and more. And very often, teachers of university mathematics are involved in all these elements, in performing all these elements simultaneously. Writing on the board, which is the central practice within this chalk talk. Writing mathematical symbols, equations, graphs, diagrams, prose, text in the language in which they are teaching. Articulating what is being written simultaneously with writing it on the board, which is a very complex cognitive endeavor, we've been told. Talking out loud about what has just been written and articulated, which is a kind of meta-discourse or language about language. Using a lot of gestures to point and connect different parts that have been written on the board, to highlight key issues on the board, to elicit student responses, to encourage students' participation, a variety of gestures, talking to students or talking with students, moving in space, a lot of moving in space. Interestingly, we've been able to code those moves, and they are typified across different local and global contexts, just as what they say is typified and what they write is typified and how they gesture is typified. Regardless of their cultural background, of course there are differences. Of course there are differences based on cultural background, linguistic background, so on and so forth. But the similarities are striking. And referring to types of texts that are not necessarily present in the classroom, referring to textbooks and exams and tests, websites, so on and so forth. And very often referring to their own lecture notes, often holding lecture notes in their hand or keeping lecture notes on the desk and looking at them sporadically. So basically, these are snapshots of what we call chalk talk. And you can see the variety. You see 5 snapshots here that come from different global and local contexts. We see a professor whose first language is Russian teaching in Spanish in Spain, a Swedish professor teaching in Sweden, an English-speaking professor teaching in English in Canada, a Russian-speaking professor teaching in French in Canada, Hebrew-speaking professor teaching in Hebrew in Israel, and we can present many more. So I just wanted to play a couple of excerpts for you that also represent, they're in English, and they represent different contexts.
Did I give the note where the classical method is faster than Karatsuba's for very small inputs, and so therefore, okay. Right, so it's what to do in the case of integers. Okay, for integers, like most things, almost everything is nearly the same, but you have to deal with some equivalence of carrying. They're not exactly the same because, of course, the algorithm isn't exactly the same. So the setup say we have 2 integers.
This is Canada, English-speaking professor. This is the States.
The log, the natural log of L of lambda. And so maximizing the natural log will maximize.
This is just 2 illustrations. A quote from a university professor, Russian-speaking university professor teaching in England. He wrote that in his online blog several years ago. Mathematics teacher is not just conveying information. He or she teaches students to think mathematically and teaches by example in real time. It is crucially important to be in full control of timing and tempo of the narrative. If a lecture involves calculations, and they are inevitable in most mathematical disciplines, it is crucially important to let students feel the subtle play of rhythm, emphasize switches and branch points in the procedure, highlight recursion and reduction to simpler cases. It's a mathematician writing. But I think you can see in this quote how deeply this person understands his teaching practices. It's not that he's teaching without being cognizant of what exactly he's doing when he's teaching. It's so much more than just writing symbolism on the board. It's everything. So in our study, we used a complex theoretical and analytical framework that combined rhetorical genre studies, situated learning communities of practice, multimodality, and gesture theory. I'm not going to speak a lot about our theoretical framework, but I will introduce these theories very briefly just for you to understand what we're talking about. So rhetorical genre studies is an approach to studying typified kinds of discourse, where by discourse I mean text, but not necessarily written or oral. It may be multimodal text, that includes even movement. So rhetorical genre studies sees genre, which is these typified kinds of texts, as relatively stable types of utterances that are used in communication among people and that connect people in the process of communication. Traditionally in literature, genres were and still are considered as types of written text and types of oral text that you can classify by the kind of language that is used in them. Rhetorical genre studies looks at what those genres do in a social context and then look at the textual realization of these actions as consequences of what the genres do. Right? So the purpose of rhetorical genre studies is not to classify different texts. It is to understand what social action is performed by those texts. And then, as linguists, we look at how it is realized through language. Genres are, as I said, relatively stable. We wouldn't recognize them if they weren't, as we recognize a love letter, if anybody writes love letters anymore, or a text message, or a blog, or a textbook, or telephone bill. Those all are genres, right? But they are only stabilized enough in a particular time frame where we live, or if we study historical genres. Because as with love letters, they have either completely disappeared or are disappearing in the void. And at the same time, because genres are stabilized, in a sense, they constrain their users because users have to follow particular conventions to make sure that their texts accomplish a particular social action. At the same time, as Bakhtin said, if you have mastered the genre, you can improvise on it. Just like in jazz, you need to have your melody, and then you can improvise. This rhetorical genre theory is compatible with other theories that we use in our theoretical framework. And it's very useful in understanding how genres are learned by novices or by novice university teachers of mathematics, for example. So it is a definition of genre. I'm not even sure that you need to know it, but read it. But what's important is that there are words. There is a word organization that is included in this definition. Constellation of overtly recognized rhetorical conventions and tacit and improvisational strategies, as I just described to you. Particular rhetorical conventions, rhetorical in a sense that the way language is used to accomplish a particular social action, but also a lot is tacit and not articulated and improvisational. And they come into existence when an individual is being socialized in an organization. And by organization, in this study, we understand the discipline of mathematics in university, or any discipline at university. That is embedded in nested context that I showed you, in larger nested context. Another theory we drew on is a theory of situated learning, where learning is considered a social process that involves an individual who actively participates in the processes of social communities, such as teachers of university mathematics who participate in the practices of the community of university mathematics teachers. And there's a notion of community of practice, or COP, which is defined as being formed by people who are engaged in a process of collective learning and doing something, where they share goals, values, and beliefs. And so we perceive mathematicians as a community of practice. We also perceive mathematics teachers, university mathematics teachers, as part of that community of practice. So when we're coming from writing studies, so what is this? Is there anything about writing? There is, of course, the writing on the board that is crucial and central to teaching mathematics. But we also drawing on other literature where we see writing beyond just presenting symbols on the board. And we see mathematical language and mathematical writing as this chalk talk that includes writing and speaking and movement and gesturing and other things. So, because of this view of writing, we started drawing on the theory of multimodality. And once again, multimodal text is a combination of everything that I just presented to you. So I think I'm going to skip theory. Because we work within this multimodality theory or mediated discourse theory tradition, we look at different modes. And in our study, the most important modes that we observed are writing on the board, speaking, and movement. And movement includes gaze, directionality, and gesturing, and so on. So because of moving away from the text, written text, into multimodality, we had to find a definition of utterance, because stabilized utterance is a genre, as we just discussed, beyond verbal discourse. And we found one with Camden, who is a gesture theory theorist, where he defines utterance as any ensemble of action that counts for others as an attempt by an actor to give information of some sort. And then communication can occur through speech and through visible bodily action, or through combination of these two modalities. So then we started using this definition. Our research has shown that chalk talk is the central pedagogical genre of the undergraduate mathematics classroom. We mostly looked at undergraduate mathematics classrooms because of the problems that have been identified with failing students in undergraduate classrooms, and because of the transition between secondary high school to university. This is the central practice. This is how mathematics is done, regardless of the local or global context. And so in our definition, it is a genre. This pedagogical practice is a genre of teaching mathematics that includes both verbal and nonverbal features. So we looked at 11 Canadian international sites, different nested contexts. Now we have more than 50 participants, but what I'm talking about is based on 50 participants, 12 females, 38 males. Our study includes 16 first languages and 8 languages of instruction. This is a very brief outline of who our participants were, what status they had in the institution where they taught, and what first languages they spoke. And you can see a huge array of languages that we have here. So we needed a multimodal record of these multimodal processes, and we turned to video recordings. So our data is video recordings of classroom teaching, interviews, audio recorded interviews with professors, and all sorts of written artifacts, their notes, textbooks, websites, so on and so forth. Also follow-up interviews and follow-up email communications and field notes observations. We used particular methods of analysis, often used in social sciences, modified constructivist grounded theory. We used analytical software for qualitative and quantitative research and vivo, and conducted multimodal analysis of video recordings and gesture analysis that my master's student, Chloe Fogarty-Bourget, just completed, and her thesis, I'm so proud of it, has been nominated for the University Medal at Carleton. We've done some descriptive statistics, and we went back to our participants and showed them what we saw. These are snapshots of the software in vivo. I think some of you might be familiar with that. This is how transcribed lecture, oral production in lecture is analyzed. And this is how multimodal coding is done in vivo: gestures, movement, gaze, so on and so forth. So, like I said, the most important primary modes are writing on the board, speaking, and movement. One of the parts of this chalk talk that appeared extremely important is what we started calling board choreography, or how professors manage what they write on the board, what they erase on the board, how they move along the board, and so on and so forth. And one of the veteran university teachers said that a lot of thinking goes into the blackboard. You need to think what to keep, what to erase, where to write it so that it would not get in your way if you want to keep it for a while. And there's some quotes about how important it is for mathematicians to have blackboards in their classrooms. And it's no way, we've encountered several cases when universities removed blackboards, chalkboards from all classes on campus, installed computers instead, or even whiteboards that reflect the light, and it's very hard to write on them. And how to manage multiple sliding boards, as this quote at the bottom of this slide illustrates. Can you use another 5 minutes?
Yeah, you have 10 minutes.
Oh, lovely. So I just wanted to illustrate something, if it's going to work here.
It's produced from Y1. Yes, that's W1 minus W2 equals 0. Next, W1 equals. Okay, so any questions?
So these two excerpts juxtaposed, I just wanted to show you what we mean by board choreography. The first excerpt from a lecture by an extremely renowned mathematician, Russian-speaking. My first language is Russian, so we have a lot of Russian-speaking mathematicians, and there are a lot of Russian-speaking mathematicians around. Teaching in Hebrew, his fourth language, in Israel. And what I wanted to show you was how he was managing those sliding boards. And I don't know if you noticed, but when he started moving the board, it got stuck. So he went to the desk, he put down his highlighters, his markers, he put down his notes, he went back to the board, and he moved it because it was crucial for him that what was behind that moving board had to be there for students to see it for the duration of the next part of the lecture. And the way he knew exactly on which board he would write one part of the lecture, move it up, keep it there, and on which board he would write for the remainder of the lecture. The second excerpt is a postdoc, also a Russian-speaking postdoc, teaching in an American university in English. And, well, what can I say? He was an extremely tall fellow, and he was gradually disappearing as he was writing. He would not push that board. You know, I just couldn't understand. He would not push that board. There's 3 sliding boards, one behind the other. And he would not. He would go down and down and down and crouch so that he completely disappeared. But I don't know if you noticed, he never stopped talking. And he was not necessarily only articulating what he was writing. He was saying, are there any questions? As he was writing. So I showed his whole lecture, this postdocs. I played it back to him, and we discussed what was happening. And he said that he was getting students' evaluations all the time. There were negative comments on his writing on the board. And he thought they were criticizing his handwriting. It would never occur to him that there was something in how he manipulated the board. So, I mean, this is just an interesting comment. However, he was doing exactly the same as all other professors, except how he choreographed that board. So we looked at the mode of movement, in particular body positioning, shoulder line, focus, directionality of gaze, gesture, facial expressions. And I'm just going to show you this very quickly, how much work went into it, into analyzing the multimodal side of this genre of teaching. This is how we started doing it. It's our initial, we actually continue with this way of analyzing. You can see timestamp and major modes involved in this performance: talking, writing, and the movement. And within the mode of movement, there are, of course, endless possibilities to look at within movement. And here we looked at body and shoulder line orientation and focus. Focus being on the board, on the notes, on the textbook, on the students. And you can see that this is 24 seconds, a 24-second excerpt from a lecture by this renowned professor. And you can see how he moves and how his orientation changes from facing his classroom to turning to the board and writing, to looking at the notes, to turning into half turn, looking at the board and at the students. And often, anecdotally, I'm sure you do, and I hear all the time, our professor always writes on the board in mathematics, and his back is to the students. Even in a 24-second clip that we analyzed here, this is not happening. So these kinds of tables, these kinds of analysis allowed us to quantify and see what is happening within those segments of teaching, and also how time and space are important to the performance of this teaching genre. And then, with my student, we went into gesture theory, looking from Camden's perspective. Gesture and speech are employed together as partners in a single rhetorical enterprise. And the speaker works to create an ensemble of meaning. And everything I have covered so far, and that I'm going to cover very quickly, is all about creating mathematical meanings. So these are just two examples. This is a very experienced professor, an American professor teaching in the States. This is one of the gestures that my student identified. She was looking at gestures used by university mathematics teachers to elicit student responses and to promote student participation in the lecture. One of the gestures that this professor used a lot, other professors as well, was to point at a student and ask them for an answer. This is a TA, and this is another gesture that was very often used. It's an open hand supine gesture. It is used to indicate something that has been written on the board that he is going to talk about. So produce this meta discourse, text about text. And I mean, she looked at many gestures, very good work. So this multimodal analysis allowed us to see how these components of the three main modes unfold in time space, and what is similar and what is different in this multimodal enactment of this pedagogical genre across contexts and among veteran and novice university teachers of mathematics. Striking similarities, more similarities than differences, definitely. There are differences. There are differences depending on personality, obviously, upbringing, national culture, ethnic culture, so on and so forth. There are differences clearly between novices and veteran professors. So the conclusions of this study, at this point, it's ongoing. First of all, we identified a genre that crosses all the nested contexts that we looked at, both global and local, which we've come to call chalk talk. It is a meaningful disciplinary practice. It is rooted, we also looked at practices of professional mathematicians, research mathematicians, and they use chalk talk just as well as they use it in the classrooms. It is a deeply disciplinary professional practice that has meaning and that is shared by the members of the community of practice of mathematicians. There's certainly a tendency in mathematics professors to see their teaching, the way of teaching, as a way of introducing students to how mathematics is done and what mathematics is. And there is a great disparity, especially now, between how mathematics is taught in elementary and secondary contexts and at university. It is impossible to study what is written on the board separately from what is said, separately from how the professor moves, separately from how it's written on the board and how the board is managed. It's all intertwined. It can only be studied as multimodal performance. And contrary to some descriptions of university mathematics teaching as unengaged and unengaging, as I showed in current research at the beginning of today's presentation, university teachers of mathematics, those whom we observed in this study, were always engaged and always interacting with students, even when they had their backs to the students. So this deeply disciplinary genre includes engagement, includes interaction, but it is a different kind of engagement and interaction than in many social science courses, and attempts to transfer what is done in social science classes to engage students onto how mathematics is taught is trying to cross disciplinary boundaries that are much deeper than whether students talk to each other in the classroom or not. And once again, I want to stress it, there's no university that teaches mathematics only through lectures. And this somehow is being lost in many of critical views of how mathematics is taught in university. So the implications of this study and directions for future research. Implications for future research, we need to learn more about disciplinary genres, not only in mathematics, in different disciplines. We need to understand better the relationship between global and local disciplinary communities of praxis, disciplinary communities in disciplines, and will increase our understanding of academic literacy overall in effective teaching and learning. Findings of our study may help in training novice university mathematics teachers in disciplinary pedagogical practices. This is already practiced in many, many departments of mathematics across the world, but not everywhere. It is mentorships that are internal to the discipline. It's also important, and this is one of the implications of our research, it is very important to have a critical view of disciplinary tradition and innovation. And what I mean here, and this is probably very much contrary to how the word critical is interpreted. I think we need to be very critical towards the innovation until we fully understand that the innovation is compatible with disciplinary practices. For future research, of course, we need longitudinal studies of novices as they become members of the community. And most importantly, we need to look at the interactions between teaching and learning mathematics and other disciplines, but for us, mathematics in university. And this is the next study that we're planning with my colleague, Jana Fox, and the impact of technology on the university mathematics classroom. And this is one of the issues that I meant when I said the critical view of innovation is very important, because often technology is introduced into classrooms that are not suitable for this technology. Oops, this completes my presentation. Thank you very much. I hope I didn't take more time.
Thank you, Natasha. Well, maybe if you want to grab a coffee for the 15 minutes of question periods, because the coffee arrived late, so not everyone. And otherwise, I will let Natasha lead the question period if there are any questions.
I have a question.
Yes.
And I apologize for arriving late. I taught at the other end of campus, went to the office, and
I totally understand.
and I was trying to find as many shortcuts as possible without having to go outside.
Could you please tell me where you come from?
I'm a colleague of Monica's. So I teach, my area of interest is non-native speaker teachers, specifically with languages.
Okay.
So I was intrigued when you were describing that you had non-native speakers, Russians teaching in Hebrew or in English and so on. So I wanted to know, did you notice if that had an impact on their Choctaw? Did it have an impact, the fact that they weren't native speakers, did it affect the volume that they wrote on the board? Did it affect how they interacted with the students? Did it affect, or the styles and the way they would have engaged with the students?
No.
At all?
Not at all. People I looked at are very proficient speakers of their additional languages. No, I have not observed that. I looked at it very, very carefully because from the beginning I thought that my focus would be on non-native speakers teaching in their additional languages. Accents.
Yes.
Accents, of course, yes. Nothing else. There was one case when a professor commented, a Russian speaker teaching in Hebrew in Israel, he said to me that he has taught for years, not the one that I showed you. And he said that it was still extremely difficult for him to manage writing on the board, not in the terms of choreography, but in terms of actual writing, because in Hebrew, you write right to left, mathematical symbols. He was writing left to right, and a lot of Latin expressions that always are written on the board in mathematics lectures are also left to right. So he said it was very hard for him to keep it straight.
And no comment about not being able to understand the students, if the students were speaking their outline?
No. No, they commented on the differences they observed in the students. Apparently, there are a lot of differences across the context in how students behave, but not in terms of the actual teaching. Yeah.
So I have two questions. One is kind of following up on Sheila's question about language, and it's very brief, and then I'll move on to the second one. So my first question was, you mentioned there was a variety of languages in which these professors, postdocs, teaching assistants who were observed. And so in terms of methodology, should someone translate? Did you speak some of these languages? And how did that work in terms of coding and analysis? And then my next question would be, you mentioned a couple of times that that these are very proficient speakers in this complex multimodal discourse. And you mentioned globalization, and you said that there's a lot of similarities that you saw across. So is there some sort of summary of these similarities? Is there a common core of features that these professors all exhibit when you observe them, regardless of the language that they speak in the class or their classmates?
Can I start with the second part of your question? What the similarities are striking, and the similarities are chalk talk. All these elements, exactly as they are presented here, are recurrent in every single mathematics classroom that we observe. All of them. Okay. There may be more emphasis on something, but they all exhibited the same features. And this is why we understood that this was a genre, that is, a stabilized way of teaching mathematics at university.
And this would be different from teaching in social science?
I can only comment on this anecdotally or from the literature that I've read. At one point, we spoke about history and with historians. And they, once again, attested to the fact that if you go to history classrooms in different countries, you will definitely see different kinds of teaching. Okay, I haven't done that. I cannot comment on that. Okay. Going back to your first question in terms of languages, some of the languages we speak among ourselves, like my colleague and I. For other languages, we hired informants, speakers of those languages. So we had, I understand very little Hebrew. I can sort of figure out what they're talking about, but I cannot translate. So we hired a Hebrew informer who went through all the lectures with me and basically interpreted. And we recorded that. We had a Swedish informer. We now have recordings in Persian, and we are looking for a Persian informant. We unfortunately don't have Chinese records and Arabic records. This is what we're looking for. European languages we sort of cover, more or less. Russian I speak.
You look
have a point of clarification. On the screen, when you've identified using a variety of gestures too, then you've given the references. You've got 2011 Fox and Earth.
Yes.
The other one doesn't have a date. It says 2001.
It's 11. Sorry, I apologize.
Okay, thank you.
It's a typo.
I just had a comment. On Friday, I went to a workshop on using a smartphone. I just thought about that when you came in. And everyone else in the workshop was from the math department. And the person who was leading the workshop said, you know, why are you here? And they all said, it's because we don't have enough board space anymore. So that I just wondered, you mentioned at the end that that's sort of the next direction of your research, is to look at how innovation impacts teaching. But did you look at that at all?
Yes.
Because you said there were some classrooms where, you know, they didn't have any boards.
Yeah. Yes, we looked at it specifically, Carla. I just didn't include it because otherwise I'll keep you here. I would have kept you here until evening. First of all, when we started this research, when we applied for the grant, we thought that when we look at novices who are just coming out of university, that they would be much more adept in using electronic communication and would be bringing electronic communication into their mathematics classroom. Not at all. There was no difference in what PhD students, postdocs said about using electronic equipment in the classroom. I'm not saying that they negated it completely, not at all. But there was no difference between what they said and how they used it and what veteran professors said and how they used it. It's not that it's not used. It is used. But it cannot be used instead of the board. Unless it is a smart board, which I don't know about. Surprisingly, when we had already published about Chalk Talk, I met a professor from Germany, and we had read publications by a group of German professors who created an electronic way of teaching mathematics in Germany, and they called it e-chalk. And then I was at an American university, and he was a visiting professor there, and I met him there, and he explained to me what they did. And they had large classes of students, and they created basically smart board technology. There were big screens in the classroom that students could see from different points in the classroom. The professor could write on the board. It would be recorded and saved as a file. Graphs would be saved as a file. At the same time, if they wanted to play a simulation, they would play it on the smart board, and students at a distance could access it through computers. Yeah, but writing would be in real time, and it would be handwriting.
It was very interesting because I think it sort of puts the finger on the idea that like some disciplines you're teaching content, and so it's maybe not so important to use the board. But when you're teaching process, you have a challenge because black on white slides just doesn't, it captures the product, not the what happens to get there. And I think mathematics is an example, and so you see the teachers board. I think it's interesting to see the difference between the novice professors and the expert professors, and so they're developing consciously or unconsciously a sense of the strategies and the things they can do to organize well before it organizes the talk. Do you think the same kind of raising of awareness of the genre, the talk shop, could be good for the students also, those students who are struggling, by making them aware of, okay, this is what you should expect, but this is how you might, you know, have 3 pieces of paper, 1 for each board, to help their comprehension or help in their dealing with those difficult things that they're facing.
There are publications by mathematicians who think it would help. There are publications by genre scholars, not about mathematics, who think it may help. There are also opinions by genre scholars that it may hurt. I don't know. I have not done any research myself. I've read literature in which mathematics professors said that they developed this kind of teaching, and they did that. But what they meant by this kind of teaching was explicit teaching of mathematics grammar. Apparently, they say that performances in their classes improve. Maybe. But I'm convinced, and I apologize, I'm convinced that there is something seriously wrong going in schools. And students come to university without understanding what mathematics is and what it is about. And mathematics is not arithmetic. And mathematics is not what you can invent without knowing the basics. Okay. It's not, you must understand what it is about. You must understand that mathematics is a different way of thinking about the world. It's a different way of thinking. And if teachers who don't understand that teach students in schools mathematics, it's going to be what it is. It is my personal, individual opinion, and I certainly apologize to you. And in terms of genre, I think what is important is how new teachers are entering the genre. And I think they learn a lot just by being in the classroom, you know, and being teaching assistants. But there's also a lot that can be a little bit, you know, a little push. One of the professors at Carleton did his PhD at MIT. He was telling us that his mentor videotaped all his teaching and then would send him long emails discussing everything he did in the classroom. And he said that it was years and ages ago. He still keeps all these emails, and he gave them to us. You see, on the other hand, this Russian postdoc, he was not even aware of what he was doing.
Because as I'm listening to you, I'm realizing, like, part of the problem is we need to really teach mathematics. Maybe you need to teach that. But what the students are, I mean, it's not an accident that you were able to do this study because you have video. But the students, most of them are not videotaping, not having access to video record of class. I'm just wondering, again, going back to what students could do to try and capture that multimodality, to rethink, go through the steps. Otherwise, they're stuck with something very
static. Yes.
Then they may not be able to get it.
I agree with you 100%. There are possibilities like that. Some universities are doing that. We also observed a very bizarre practice, as far as I'm concerned. You can find it on the internet because many universities now make their lectures available on the internet. And if you look at Berkeley and MIT, they actually video record the whole lecture with the professor, and they follow professor's movement and so on. You can also find older recordings when the professor is writing on the transparency and all you see is the professor's hand. And what I observed in Australia, they have this really sophisticated technology where the professor is writing with a special pen on a special piece of paper, and it saves what he's writing as a digital file. But you can only see the hand. And I've watched several lectures, and you hear the disembodied voice. I don't even understand how you can learn mathematics like that. You know, and I think they're doing terrific mistake, terrible disservice to their students by doing that. While the administration certainly thinks that what they're doing is great because students have access to these files on the computer. So to me, what the Germans did with the e-chalk, I think it's good. I don't know whether it's the best, but I think it's a step in the right direction. Not that I think that the right direction is away from the board. I actually think the right direction is towards